Perfecto. En lo que el resto de la gente va entrando y se va uniendo a nuestra charla, quería darle la bienvenida a todos al evento de lanzamiento del Chapter de Latam de NeuroTechX. NeuroTechX es la comunidad internacional más grande de entusiastas de la neurotecnología. Tenemos 3 pilares. Nuestros pilares son comunidad, educación e innovación. Comunidad se refiere a la necesidad de diversidad y de dinamismo en las comunidades de expertos. Y educación es que hacemos accesibles recursos para personas que quieren empezar en este mundo, ya sean novatos o ya sean expertos. Innovación, porque tratamos de inspirar a la comunidad a resolver problemas utilizando este tipo de tecnología tan nueva, ¿no? Tenemos capítulos en todo el mundo. Tenemos más de 16,000 miembros. Tenemos más de 25 capítulos en diferentes ciudades de todo el mundo. Y ahora estamos lanzando oficialmente los capítulos que conforman la comunidad latinoamericana. En esta ocasión estamos conformados por los capítulos de Bolivia, los capítulos de Uruguay y de México. Este es nuestro evento inaugural. Sean todos bienvenidos. Si quieren estar en contacto con NeuroTechX, es muy fácil. Síguenos en nuestras redes sociales y en la web. Ahora, sin añadir mucho más, quiero presentarles a los representantes de ActivePulse que tenemos hoy, Adrián Chatillon y Gabriel Villafuente. Sin nada más que agregar, el escenario es tuyo, muchachos. Muchas gracias.
Gracias. Yo primero quiero saber dónde consiguieron esa foto de Gabriel.
Algo un poquito gordito. Estaba más gordito, pero bueno. En Google, es la que sale en Google.
Pues chicos, gracias por la invitación. Yo soy Adrián Chatillon, soy el CEO de ActivePulse Neuroscience y Gabriel es el director científico. Como esto está en la streamada de StandStream y hay mucha gente, pues infortunadamente no podemos dar muchos detalles de ActivePulse, ¿no? por temas de propiedad intelectual y de estratégicos, pero con mucho gusto podemos presentar la empresa en su globalidad, en lo que estamos haciendo y cómo lo hacemos sobre todo, ¿no? Porque somos una empresa de neurotecnología en México y hemos aprendido a hacer mucho con poco, ¿no? Entonces, sobre todo es lo que podemos discutir, sobre cómo hacemos estudios clínicos aquí en México, cómo aprovechamos de hacer muchísimas cosas con los pocos recursos que estamos y que tenemos en América Latina. Creo que es lo mismo para todos los países latinos presentes. Entonces, para darles una introducción de ActivePulse en grandes rasgos, nosotros fundamos la empresa hace 5 años y estamos especializados en estimulación cerebral no invasiva para el tratamiento de patologías neurológicas y psiquiátricas. Ya estamos en el mercado para el tratamiento de la depresión. Ustedes como son del gremio, como decimos aquí en México, de seguro conocen la estimulación magnética transcranial, que es lo que nosotros, es la técnica en la cual nos especializamos. Tenemos... Perdón, es que consigo la oficina más barata de la Ciudad de México, entonces hay mucho ruido. Entonces, es la misma técnica que utilizamos, al ver con un poco diferente, con unas frecuencias e intensidades diferentes. Y lo que hacemos desde los últimos años, pues, es investigar, primero para patologías psiquiátricas, como la depresión y la ansiedad, y patologías neurológicas, como el Alzheimer o el Parkinson, por ejemplo, o la rehabilitación post-TBC. Somos 21 personas aquí en ActivePulse. Estamos la mayoría basada en la Ciudad de México y pues ya tenemos un dispositivo en el mercado para tratar la depresión. ¿Cómo lo hacemos? Pues ustedes saben, cuando alguien tiene depresión, el paciente va a ir a ver un psiquiatra. La primera línea de tratamiento son fármacos, pero muchas veces, que son 4 sobre 10, los fármacos no funcionan sobre algunos pacientes. En este caso es cuando se propone una segunda línea de tratamiento, que es la estimulación cerebral no invasiva, y un paciente requiere más o menos unas 30 sesiones. Una sesión dura unos 30 a 45 minutos. Y eso permite a alrededor del 70% de esas personas que utilizan esta terapia de llegar a remisión. Esto es nuestro trabajo para la psiquiatría. Estamos ahorita muy metidos y tenemos unos estudios corriendo para enfermedades neurológicas que hacemos aquí en México. Entonces, ahorita Gabriel, quien es el director científico, es el que se encarga de todas las investigaciones, así que voy a dar un par de palabras de lo que se investiga hoy presentemente, sin hablar mucho del futuro.
Claro, claro. Buenas tardes a todos, muchísimas gracias por la invitación. Y nada más quiero hacer énfasis en una cosa que Adrián dijo que es muy interesante, y es la parte de Latinoamérica. La neuromodulación desafortunadamente no es muy accesible en el mundo, sobre todo en esta parte del mundo, y una de las misiones y valores de Articles es justamente hacer accesible la neurotecnología, ¿no? Una sesión de TMS en Estados Unidos está alrededor de $400, y aquí en México hemos podido bajar el precio a unos $50 por sesión. Entonces, aunque somos una empresa, tenemos esta responsabilidad social muy importante de poder democratizar el acceso a estas tecnologías en Latinoamérica. Y bueno, como les decía Adrián, nuestra tecnología es bastante única. Está patentada, es una tecnología que se desarrolló desde cero dentro de la empresa. Es muy similar al TMS, sin embargo, utilizamos frecuencias más fisiológicas, en el sentido de que son frecuencias en las cuales el cerebro está disparando, y utilizamos intensidades de campos magnéticos más bajas, pero que aún así son capaces de generar cambios biológicos. Me gustaría platicarles un poco de los estudios y las publicaciones que hemos tenido a partir de lo que hemos hecho en estos años. Creo que voy a empezar de menos a más, ¿no? Y les platico así como el más ambicioso al final. Empezamos con algunos estudios en depresión, ¿no? En pacientes, reportes y casos, donde vimos, como decía Adrián, unos resultados muy buenos. La fisiopatología de la depresión es una fisiopatología mucho más compleja de lo que creemos, no es nada más una cuestión monominérgica. Tiene que ver también con la plasticidad, sobre todo de la corteza prefrontal dorsolateral izquierda. Y se cree, ¿no? Porque es lo que se ha visto en la literatura, que la estimulación magnética aumenta la activación cerebral, aumenta el metabolismo cerebral en esta zona, en la corteza prefrontal dorsolateral izquierda. Entonces, al aplicar la estimulación en esta área, pues es cuando vemos una mejoría clínica en los pacientes. Otro estudio que hicimos fue relacionado a tabaquismo. El tabaquismo, como saben, pues es la primera causa de cáncer de pulmón, ¿no? Una gran cantidad de problemas de salud. Probablemente si todas las personas dejaran de fumar de un día para otro, las muertes se reducirían dramáticamente, sobre todo a nivel de infartos, a nivel de stroke, a nivel de cáncer. El tabaco es un gran factor de riesgo, y nosotros utilizamos nuestra tecnología justamente para ver si podíamos modular el circuito de recompensa. Se ha visto que la estimulación magnética transcraneal favorece la liberación de dopamina cuando se aplica sobre la corteza prefrontal, y justamente esa era la premisa o la hipótesis que teníamos, ¿no? Que podíamos disminuir el craving en las personas que estaban dejando de fumar. Y por último, tal vez el estudio pues, más grande y más ambicioso que hemos hecho es un estudio de seguridad, es un estudio de piloto para ver y probar que podemos utilizar este tipo de neurotecnología a largo plazo. ¿Y por qué la importancia de que sea a largo plazo? Porque, bueno, cuando una persona tiene un episodio de depresión mayor, se pueden dar 30 sesiones y hay una remisión. Pero ¿qué pasa con enfermedades neurodegenerativas que siguen avanzando, que no se detienen, que la historia natural de la enfermedad va hacia una progresión? Nuestra hipótesis es que no es suficiente. Una de las razones por las cuales han fallado muchas intervenciones de neuromodulación en el área de las enfermedades neurodegenerativas es porque no es suficiente aplicar la estimulación 20, 30 sesiones. Probablemente sea necesario aplicarlo por un tiempo mucho más prolongado e inclusive de por vida. Sin embargo, si han leído un poquito sobre TMS, prácticamente no hay ningún estudio que haya aplicado la estimulación magnética transcranial por más de 8 semanas, 12 semanas. Y nosotros hicimos un primer estudio donde aplicamos la estimulación, ¿no? Primero por 6 meses, 2 veces al día, lo que se convirtió en prácticamente unas 700 sesiones de TMS, no, perdón, unas 360 sesiones de TMS, de 30 minutos cada una. Y lo interesante es que desarrollamos un dispositivo para que el paciente lo pudiera hacer desde casa, ¿no? Y esto se aplicó en pacientes con deterioro cognitivo leve y demencia leve con el fin de evaluar qué tan fácil era que lo pudieran utilizar. La verdad es que nos encontramos, ya se publicó estos resultados y estamos bastante emocionados con lo que sigue en el futuro con respecto a nuestra tecnología y a este posible tratamiento de enfermedades neurodegenerativas, donde definitivamente hay un vacío muy grande que los fármacos hasta cierto punto no han podido cubrir.
Quisiera agregar lo que dice Gabriel. Estar en América Latina es una fuerza, no una debilidad, ¿no? Muchas empresas de salud, de startups de salud y tecnología dicen, es que estamos en América Latina, hay no recursos. Y eso es cierto, a veces hay que pues, buscar más que tal vez en empresas en Estados Unidos o en Europa, pero eso hace un poco la fuerza. Hay un dicho en México que dice falta de pan tortilla, entonces pues hay que encontrar la manera, ¿no? De encontrar, de sobrevivir, de buscar los medios, y eso hace que seamos mucho más ágiles que otras empresas que vemos, por ejemplo, en Estados Unidos, que ellos levantan muchísimo capital, pero después no lo usan muy bien, ¿no? Y eso fundamentalmente es un problema ético detrás, porque una investigación clínica cara se va a transformar por un terapéutico caro, que ya a lo mejor hay pacientes que no van a poder comprar o acceder a ese tipo de tratamiento porque la empresa tomó malas decisiones desde el principio. Entonces, nosotros haber empezado en México y lo vemos como una oportunidad y esperamos que ustedes también sea así, ¿no? Que todo lo que estén haciendo en su país veanlo como una oportunidad de aprender con menos recursos, y cuando caen los recursos, pues es aún mejor porque pueden multiplicarlos, porque ya han pasado por esa escuela de saber cómo generar más con menos recursos. Entonces, lo que quisiera agregar. No sé si ustedes tengan preguntas, con mucho gusto las contestamos.
Gracias, muchas gracias, muchachos. Sí, un par de preguntas. Aparte de, digamos, los tratamientos que están viendo con estas enfermedades, eh, ¿qué otras enfermedades se podrían tratar con este tipo de tecnología no invasiva, ¿no? Si
Mira,
es que hay...
claro, claro. En realidad se han intentado tratar no necesariamente con nuestra tecnología, sino con múltiples tecnologías no invasivas, desde TDCS, TMS, TACS, prácticamente cualquier enfermedad neurológica y psiquiátrica que nos imaginemos, hay por ahí algún reporte perdido en PubMed, ¿no? De alguien que lo intentó. La realidad es que, pues, aunque lo han intentado muchas cosas, no son tantos los padecimientos que de verdad se ha visto un efecto clínico. Donde más efecto clínico, y está más que demostrado, y creo que la mejor justificación para decir que está demostrado es que hay seguros en Estados Unidos que pagan el reembolso de esto, es en depresión, ¿no? Entonces, en depresión hay muchísima evidencia. Secundariamente, depresión, trastorno obsesivo compulsivo, también está aprobado por la FDA en Estados Unidos. En el 2020 se aprobó también para dejar de fumar como un adyuvante. Y recientemente, literalmente hace un par de semanas, se aprobó para personas que tienen síntomas de ansiedad con depresión. O sea, tienes que tener depresión, pero aparte que tengas muchos síntomas de ansiedad. Creo que estas son las patologías que están aprobadas como por un organismo regulatorio. Sin embargo, off-label, es decir, sin esta como indicación, se ha utilizado para enfermedad de Parkinson, para rehabilitación de stroke, rehabilitación de evento vascular cerebral. Se ha utilizado también para algunos trastornos del neurodesarrollo, como el déficit de atención y hiperactividad y el trastorno del espectro autista. Cuando digo se ha utilizado, digo, bueno, hay evidencia de que puede funcionar, pero hoy por hoy tampoco hay todavía no es un tratamiento de primera línea. Creo que donde hay más futuro en este sentido es en las enfermedades neurodegenerativas, sobre todo por lo complejo de la fisiopatología, donde difícilmente un solo mecanismo de acción es el responsable de toda la cascada de acciones, ¿no? Entonces, las técnicas de neuromodulación tienen diferentes mecanismos de acción en una sola aplicación. Creo que en las enfermedades neurodegenerativas pues tienen un potencial importante.
Gabriel, aquí hay una pregunta que habla sobre la misofonia.
¿Sobre la qué, perdón?
Misofonia y la estimulación.
Misofonia, supongo que no le gusten ciertos sonidos, ¿no? Supongo que eso se refiere.
Sí, creo que es la primera vez que yo lo escucho, ¿no? Pero
pues
básicamente una
por griegos
intolerancia.
me suena misos, odio, fonos, sonido,
Sí,
¿no? Entonces, supongo que es intolerancia al sonido. Se ha utilizado para lo que se conoce como tinnitus. El tinnitus es una enfermedad muy compleja porque aún puede tener causas periféricas, causas centrales y causas corticales, ¿no? Y sobre todo tiene una muy baja tasa de éxito los tratamientos convencionales para el tinnitus, que es literalmente estar escuchando un sonido todo el día. Y para el tinnitus se ha visto buenos resultados. ¿Y cómo se utiliza? Se utiliza sobre la corteza auditiva de forma inhibitoria, aunque le llamamos estimulación magnética transcraneal o TMS. En realidad tenemos dos efectos. Tenemos un efecto excitatorio y un efecto inhibitorio, dependiendo de las frecuencias que utilicemos y las intensidades y patrones que utilicemos. Muy parecido como en TDCS, donde pones el cátodo y el ánodo, que puedes tener dos efectos contrarios. Bueno, en TMS también tienes este efecto excitatorio inhibitorio, y cuando se aplica de forma inhibitoria sobre la corteza auditiva, tiene efectos positivos en tinnitus. Y veo también que nos preguntaron sobre trastorno psicótico. Justamente en la misma fisiopatología, en las alucinaciones auditivas de personas que sufren de esquizofrenia, también se aplica de forma inhibitoria en la corteza auditiva, ¿no? Como para tratar de inhibirlas.
Sí, aquí hay una pregunta sobre qué potencial le vemos a la RTMS en el futuro. Nosotros le vemos mucho futuro, pero sigue siendo un tratamiento limitado a una cierta población que pueda acceder a ese costo, porque hasta que no se logre bajar los costos de este tratamiento, y eso va de dispositivos más accesibles para los médicos o los hospitales, y por ende un tratamiento que pueda dar a un mejor precio, va a ser difícil democratizar este tratamiento. Sigue siendo un tratamiento de segunda línea. Nosotros queremos hacerlo de primera línea, que por ejemplo se use en coadyuvante con fármacos desde la primera línea de tratamiento, ya que hay publicaciones que indican que al utilizar la neuromodulación con medicamentos, pues eso multiplica el efecto de los fármacos, y eso nos podría permitir de reducir la dosificación de los medicamentos y por ende sus efectos adversos.
Totalmente de acuerdo con Adrian. Creo que el futuro de la neuromodulación está muy ligado al futuro de cómo entendemos las enfermedades del sistema nervioso. Hoy por hoy, como les decía, entendemos que es una cascada, ¿no? Que algo sale mal y luego entonces van pasando una serie de eventos hasta que te da la enfermedad, como en Alzheimer, que hablamos de que hay una cascada causada por el péptido amiloide. Cuando quitamos, o la hipótesis es muy fácil, ¿no? Pues quitamos el péptido amiloide y deberíamos de quitar el Alzheimer. La realidad de los estudios clínicos nos han mostrado que no. Tú puedes quitar y reducir todo el péptido amiloide del cuerpo y aún así tener la patología. Creo que aquí estamos en un momento de transición en donde vamos a empezar a cambiar nuestra forma de entender las enfermedades. Vamos a empezar del sistema nervioso, en donde vamos a empezar a ver que sí es un conjunto de signos, síntomas, pero la fisiopatología detrás puede ser muy diversa. Es decir, yo puedo tener una persona que su principal causa de neurodegeneración sea especies reactivas de oxígeno, y otra persona que su principal causa de neurodegeneración a lo mejor tenga que ver con la dieta, y pueden presentar el mismo cuadro clínico, exactamente el mismo cuadro clínico, cuando son dos cosas totalmente diferentes. Entonces, la neuromodulación va a ser uno de los pilares del tratamiento de las enfermedades del cerebro. Hoy por hoy solo usamos una herramienta, ¿no? Solo usamos fármacos con resultados pues modestos, algunas patologías mejores que otras, pero en algún futuro utilizaremos fármacos, neuromodulación, seguramente dieta, seguramente ejercicio, psicoterapia, etcétera, etcétera, para tratar de atacar el problema desde la mayor cantidad de ángulos posibles.
Creo que solo nos quedan unos 6 minutitos para nosotros, que quisiera agregar que es muy importante para si aquí hay empresarios, ¿no? O emprendedores, perdón, en la neuromodulación en América Latina. Este mundo se divide en el mundo wellness y en el mundo médico, ¿no? Nosotros los invitamos, la verdad, si quieren ayudar a la gente y construir una empresa y hacerla crecer fuera de las fronteras de su país y América Latina, enfóquense en la parte clínica, porque eso es lo más importante, porque en wellness se pueden tener muchos claims, ¿no? Pero hasta que no se compruebe científicamente y clínicamente los resultados, va a ser difícil para las empresas crecer. Y hay que ser honestos que como empresas de América Latina, pues empezamos con una desventaja, ¿no? La credibilidad, ¿no? Que sea de una empresa de neurotecnología, que es en México, en Bolivia, son empresas que más las vemos en Estados Unidos o en Europa o en Japón. Entonces, no, para ganarnos esa credibilidad son con publicaciones científicas, así que siempre los invitamos a investigar, a publicar, y si necesitan ayuda de cómo hacer eso, por dónde ir, pues estamos siempre, Gabriel y yo, dispuestos a ayudar a otros empresarios, emprendedores, porque al final lo que hacemos es para el bien de los pacientes, ¿no? Siempre es nuestra finalidad.
Yo les voy a dar el consejo contrario. Adri se los dijo a los que son emprendedores, a los que quieren hacer algo. Yo se los voy a decir a los que son científicos o más técnicos. Les digo, sean emprendedores. Porque desafortunadamente, no sé, en otros países de Latinoamérica supongo que es muy, muy similar, pero en México prácticamente todo el financiamiento de ciencia viene de cosas gubernamentales. Y es por eso que no hay un financiamiento fuerte. Es difícil hacer ciencia desde el punto de vista gubernamental y es todavía más difícil llevar algo que se desarrolló en una universidad a un producto. Entonces, si ustedes están haciendo su tesis de doctorado, de maestría, de licenciatura y tienen algo que creen que se puede hacer interesante, no se queden nada más con la parte de vamos a hacerlo en el laboratorio y listo, llévenlo y vean cómo lo pueden aplicar a un producto, cómo lo pueden aplicar a mejorar las vidas de las personas. Hagan cosas que a las personas les ayuden, ¿no? Y bueno, como dice Adrián, creo que desafortunadamente o afortunadamente hemos pasado ya por todos los baches que se pudieron haber pasado, entonces ya tenemos un poquito de experiencia de qué hacer y qué no hacer, y cualquier duda que tengan desde el punto de vista de tanto científico, de cómo poder pasarlo del laboratorio a un producto, o como del punto de vista de emprendedores, de quiero formar una empresa, quiero hacer algo, no duden en contactarnos, nosotros estamos aquí para servirles.
Muchas gracias. Una pregunta que no sé si algunas personas que de repente han escuchado esta tecnología por primera vez se le están haciendo es, ¿esto tendrá potencial de hacer daño o en qué casos no está indicado, digamos? ¿No?
Claro, claro. Había un médico de la Edad Media que se llamaba Paracelso, el cual decía que en la dosis está el veneno, ¿no? Y efectivamente, hasta si yo me tomo ahorita 20 litros de agua, me va a dar hiponatremia y probablemente me vaya a morir. Entonces, efectivamente, ninguna tecnología es inocua, es algo interesante, es algo que tenemos que tener en la cabeza. Siempre tenemos la posibilidad de aplicarlo mal y hacer daño, pero dentro de lo que cabe, la estimulación magnética transcranial es muy segura, muy, muy segura. Se han reportado, bueno, más bien, lo que más efectos adversos puede tener es un dolor de cabeza, una cefalea. Un efecto adverso raro, pero que existe. Y con raro me refiero a que ha habido 50 casos en 35 años de investigación. Estamos hablando de un 0.001% de riesgo, ¿no?, de que suceda, es una crisis convulsiva, ¿no? Entonces, ¿qué se recomienda? Que pacientes que tienen diagnóstico de epilepsia o alto riesgo de sufrir una crisis convulsiva no reciban estimulación magnética transcranial, ¿no? Sería como la única contraindicación de verdad importantísima.
Gente con marcapasos, quizás.
Mira, por regulación no se permite, ¿no? ¿Por qué? Porque teóricamente puede afectar. Sin embargo, no hay ningún solo paciente en la historia de la estimulación magnética transcranial que le haya afectado su marcapasos, ¿no? Pero teóricamente podría afectar. Entonces, por eso no se...
Ningún caso reportado.
Sí, ningún caso reportado. Digo, si tú agarras la bobina y se la echas directamente al marcapasos, bueno, ahí ya no respondo. Pero si la aplicas sobre la cabeza, como debe ser, no tendría que haber ningún problema, pero no lo haga.
Claro. En su opinión, ¿qué necesita esta tecnología o qué necesitan los investigadores que se dedican a esta parte de la neurociencia para llevar esta tecnología a un consumidor más global, digamos, ¿no? Que sea más popular, digamos así?
Yo creo que pilotear, algo que nos hemos dado cuenta que es muy fácil de hacer en Latinoamérica, contrario de otros países, es hacer pilotos, ¿no? Si ustedes tienen una tecnología que tienen una hipótesis de que puede funcionar para X o Y, hagan un pequeño piloto, 5 o 10 pacientes, obtengan datos, analícenlos, obtengan alguna evidencia de lo que pueden estar haciendo. Eso puede ser su proyecto de tesis, de maestría, hasta licenciatura, de doctorado, y de ahí teniendo eso, ¿no?, que ya tienen un piloto, ya tienen algunos datos, es mucho más fácil ir a buscar algún inversionista, que le digas, mira, tengo esto, quiero hacer un estudio más grande, o inclusive pedir fondos a la universidad para decir, oigan, tengo esto. Pero creo que el primer paso es pilotear, ¿no? Que ustedes puedan pilotear rápidamente algo.
Sean cucarachas. Los gringos siempre dicen, ¿cómo podemos ser una empresa unicornio? Pero antes de llegar a ser unicornio hay que ser cucaracha, ¿no? De meterse por donde sea y sobrevivir a cualquier evento con o sin dinero. Y hay que buscar los medios, ¿no? Hasta vas a ver un profesor de universidad y siempre van a estar felices de ayudarte. Y dinero siempre habrá por algún lado o que te ayuden gratuitamente. O sea, la cosa es de ir a tocar puertas y hablar y hablar y hablar con gente hasta que encuentres quien quiera apoyarte.
Súper. Bueno, muchas gracias. Creo que no sé si hay más preguntas del público, pero ya si alguien quiere de alguna forma hacer una pregunta o hacer algo más específico, ¿cómo se puede poner en contacto con ustedes? Creo que Gabriel puso su mail, pero...
Les dejamos ahí nuestro correo, es bastante sencillo, gabriel@actipulse.com y Adrián igual, ¿no? Adrián nada más o Adrián, no me acuerdo.
Adrián.
Adrián, así como
Sí,
lo tiene ahí en su...
o por LinkedIn me pueden encontrar, ¿no? Nos encuentran por LinkedIn, buscan el nombre de la empresa por LinkedIn, ahí nos van a encontrar fácilmente y con mucho gusto contáctenos.
Exactamente.
Súper. Muchas gracias, muchachos.
No, a ustedes por la invitación.
Muchas gracias a ustedes.
Gracias a Adriana and Gabriel. Getting from Mexico City, I'm Hamid, a PhD student at National Polytechnic Institute in Mexico City, and I'm chapter leader of Neurotech MX. Our chapter is one of the newest Neurotech chapter, and it was run in 2021. We are a group of students and enthusiasts getting together and talking about the neurotechnology, about the new products and the companies that play around the neurotech. Also, we have some cool projects for next year. So if you like this sort of thing, please join us. Finding us is easy. Just searching for Neurotech MX on Twitter, Neurotech MX on Twitter or Meetup, or easy send an email to mx@neurotechx.com. Thank you to all for being with us. Thank you to Josh and Garrett and Brains at Play. Brains at Play is developing an open source framework for creating brain responsive application using modern web technology. I know Josh and Garrett has a great discussion on open source community around brain computer interface. So go ahead, Josh. Hi.
Hey, let me share my screen here. Hold on. That's my calendar. Let's go through these slides real quick and then I'll show off some of our goodies. So I'm Josh and Garrett's on the call with me. So I'm I'm a college dropout from Alaska and I'm 28 years old. I've been working on this stuff for the past few years. And then Garrett and we teamed up 9 months ago. He was working on Brains at Play as part of his master's thesis program. And then we just had a lot of synergy with what we're working on. I build affordable hardware like this. I just released this. This is my Ecg V2, and then we're working on, oh God, where did I put anything? 32 channel EEGs with a friend in Russia. These are super affordable. We're making them more affordable. And then I've got this is our latest prototype, but it's an 8-channel Bluetooth 5 device prototype. And so we can get EEG off of that. And I'm also going to build, this is a FNIRS DOT headset for your forehead. And I have a 28 sensor set also. But I have to learn voxel lighting math and some physics collision stuff to do that. So all in the process. So yeah, with that, we're trying to develop essentially like commercial grade development tools, all using the latest and greatest that the web has to offer, and it's just getting better. So now browsers support native. They support native device streaming, and so we can get USB serial data, and we can get Bluetooth 5 or well Bluetooth data. The throughputs are iffy, but we're going to figure this stuff out. And then it's also getting better every year. And then we could do web sockets and some other things. So there's a lot of options there to do device communication. And then I have a bit of game engine development experience, and I'm learning a lot of like parallel computing and everything. So I have to do a lot of the signal analysis and like the performance optimization and everything else for the web pretty much from scratch. And that's cool because it's really interesting. And I'm learning a lot of coding wizardry that I would not have an excuse to learn otherwise. And then we have this all being distributed under AGPL. My original hardware was like MIT, and I had some MIT license demos, and then we decided to go all in on viral open source, and so now if you're going to work with us and distribute with us, it's all going to be AGPL, and everybody's going to have free access to everything. Oh boy. And we're just trying to facilitate that along with really affordable hardware. And then the dream here is to I kind of just talked through half my points. so yeah, I'll get to it. But so this is the hardware stuff I've crowdfunded so far successfully. This includes this 32 channel EEG. And my friend Bernard, he's a meditation teacher, and he designed these 19 channel headsets just using a 3D printer. And I have, well, this is a bar from an unassembled 3D printer that I need to build so I can start making these myself. And we're gonna do some similar stuff for our own headsets because Bernard's super cool. He's helping us out. So what he designed those for the past few years, and then him and Dimitri, I basically just offered to help try to get this project off the ground because it's really really powerful, and they taught me how to design EEGs, and now I know textbooks worth of crap now. I didn't think I would know this soon, and this is the benefit of collaboration. So I could really encourage y'all to open up and try to collaborate as much as possible, because it's just like, I'd have to pay a lot of money to go to school for this stuff otherwise. It's free, and I'm starting to get paid to do it even. So here's some more. This is just some of the hardware. I showed you like the 16 channel, and then there's the 28 channel FNIRS DOT headset down here. So what this can do, by the way, is it takes light-based images, and then because of these are essentially like pixels right on a screen, but then you can do some wizardry by estimating the light paths being emitted from these LEDs to each sensor, and then you approximate 3D volumes that way. It turns out it's really close to fMRI accuracy, and you get the first like inch or two of what space. It's like about an inch. It's like 4 centimeters. That's the depth of penetration there. So it's really good because you can see the surface of the brain, and so you can see all kinds of metabolic activity, and then that's used like in tandem with electrical signals to do like source localization, or you can do a lot of health assessment stuff that's like very new, but it's gaining traction, and I don't know, I'm really excited for it because it's really cheap and beats the hell out of sitting in an fMRI machine. So we've got there's this other chip down here. This is an Ecg chip that my friend Jacob designed. He's not here, but he's in New York on Nantucket having a good time. He's super smart, and so he's helping me with the latest hardware design iteration. And then we're working with a group in Los Angeles also to take that same prototype design, and we're making a wrist wearable to get EMG, and then we're going to add ECG and PPG and accelerometer, and so that's going to a rehab center, and then the rehab center is going to try to get like do some biometric profiling of their patients to see if for one, for potential emergency intervention, but because they deal with overdoses and suicides, and, but also just because if we could start to profile psych patients through the day, there's all kinds of really fascinating information we can learn and potentially provide better treatment responses to these people, because it's really bad and the rates are climbing and the death rates are climbing. I don't know what it's like in Latin America, but in the US, it's pretty much a disaster with mental health and psych and all the other problems that come with that. So I don't know, I really see this technology as part of what's going to educate people, most importantly. And then also there's a lot of really interesting therapeutic interventions that we can start to apply. I mean, mostly just like assisted psychotherapy, basically objectively verifying that like you're helping this person relieve stress and helping this person learn about what stresses them out and actually showing that to them on a screen. Like really simple tools like that. It's really not magic in a lot of ways. And then there, of course, it gets into neurofeedback where you're trying to actually judge brain patterns to then make judgments about how that person's brain health is changing. And there's a lot of mystery there still, but there's still very promising or there's still very useful applications for like kids with ADHD or it's starting to prove to be pretty useful for like post-traumatic stress syndrome treatments, just because it's like some of these people have issues staying present. And so if you can give them that immediate feedback, that's really, really useful to try to ground these people. So that's my interest mainly. And then Garrett, we've started working with like some brain implant people, like Johns Hopkins, and there's a group called Utrecht in the Netherlands. They want to use our web platform framework for, well, their software sucks. So it's like we can provide just plug and play out of the box stuff for them, and then people who are using their prototype brain implants can actually then use that to train themselves how to actually use their implants. There's a lot of exciting stuff there. I don't know if you guys heard about there's like a brain implant that lets a guy who's paralyzed actually talk just using like his language cortex. I mean, it's amazing stuff. But the software sucks for it. So it's kind of a cool thought that we might get to work on some of that stuff. And then it uses all the same algorithms that you apply in neurofeedback or in just general research analysis. So it's really easy for us to kind of cover all of it. And then we're just trying to make it really, really easy to then, go from the algorithms and the systems design stuff to actual, front end user experiences. Whether for actual users or for researchers who just like need convenient software to do the studies they need. Or, I mean, we could start rebuilding medical software with this stuff, like just to run machines in hospitals. I mean, it's kind of a cool thought to think that we could collect all of this under sort of just one umbrella framework, and then it's free and open source. Anybody anywhere in the world can then suddenly gain the benefits of all this open technology. And then part of that, right, is making the actual hardware really accessible, really affordable, essentially plug and play. And like, I don't know, we're using like Zephyr to code the latest microcontroller firmware. And if you don't know what that is, it's like a Google and it's like a Google funded open source microcontroller, but real-time OS based off of Linux, except it's like 8 kilobytes. So that's like, you can build like professional, real-time microcontroller code to, like we're going to be operating 4 different sensors and sending tons of data through Bluetooth 5. So like stuff like that, you need really optimal code. So if you want to get into microcontroller coding, check out Zephyr, because it seems to be where the industry is putting its money on, at least for open source. I mean, open source is just going to take over. So we're just trying to get there first. So yeah, we have a lot of beliefs that like we can make a serious difference in the world, and part of this is like, we're trying to work with a lot of this high technology. A lot of it's sort of, people are getting PhDs in this right now in every little detail about these technologies. But at the end of the day, right, we're trying to translate, we're trying to get this to people who need it. And we're trying to develop better medical solutions. And then of course, to do that, we need to practice good science. We need to practice good engineering. We need to have ethics, and we need to understand the reasons that we're doing this, right? And that's for other people. And so what I really want to do is foster a community that, like, that's what we're thinking, like making money and all that. That's part of this, but that's only for us to sustain, the mission here, which is to actually try to better our lives and anywhere in the world too. Because I don't know, a lot of this stuff kind of sits in ivory towers in academia, and it generally takes decades for it to get out there. But there's already been 50 years of research in EEG, and the FNIR stuff has 10 to 20 years of research into it. It's pretty well, validated stuff now. There's still obviously tons of questions, but it's at the point between the affordability of the technology, like these web frameworks that just let us do any kind of software we want, and pretty much like that. It's not a lot of overhead for us to make all this stuff, right? So we're at a really good opportunity to really make some optimistic efforts out of all this technology, I think. My concern is mainly around education and mental health, and maybe not treatment, depending on how good this tech really is in psychotherapy assistance, but especially for education, though, like this really helps me teach people about what the brain even is, and what stress is, and how like you are changing developmentally, and how to train skills and all these things. And when I'm bringing it back to nervous system development, and how to take care of yourself, it's really powerful. And like case in point, it's like we get a lot of people wanting us to teach like kids how to do this stuff. And there's a lot of school groups that we're going to be able to get involved in, just so that we can teach brain science and hardware and computer science, all these ideas at different levels. And then so we're also so we committed our LLC to doing everything AGPL, and we work fairly loosely with a lot of people. My conception of this, I literally had a food co-op up in Alaska, and I'm educated in like co-ops, and I have hippy dippy values there. And what I see on the tech side is like, I want to do the same thing. I want to have a co-op where it's like, there's all these resources out there. We're all independent, driven people, right? So, and we all can find ways to sustain ourselves based off of our skill sets and whatever. And we can find, like with Garrett and I, or a bunch of these other people we work with, we find ways to work together very mutually, where without getting too into the weeds of business and, well, what's my shares and all that crap. It's like, we make it happen because we're friends, and then we find ways to sustain ourselves doing this. But then there's all these amazing, but often, very out of reach funding resources out there. And we don't want to go the venture capital route. We're thinking purely grants and just trying to do sales. And then the idea is to, we're going to build all these tools that will let anybody else, hopefully build services or end user applications or whatever on top of all this. And we're going to iterate this stuff to oblivion so that you can get anything you want out of this, right? And then that's suddenly a platform for distribution, right? And for people who say offer therapeutic services, it's like, okay, I have all this affordable stuff. It's suddenly really cheap for me to do this, and then that creates links in for us to work with like client populations and actually, develop these tools to really meet needs in a better way. And in terms of like our LLC, like, for me, it's just a way to legally sell stuff, right? Like just a way to have a bank account that like I could put money into legally. Like, I don't care about the business. I don't care about, I wouldn't call myself an entrepreneur, and it's a label that's attached to me easily, but it's not how I think, right? It's like, I'm making cool stuff. I have a mission to get it to a lot of people, and to use the best that 2021 has to offer in terms of resources and stuff that I know could easily get out to more people. And what? Yeah, I don't know. This part's in progress, but yeah, essentially we'll have this sort of loose, tech co-op thing going on here. And like, biosensing is just one area. I mean, like I said, I had a food co-op. I don't know, my friend just was telling me today that he just finally, like one of my friends that I worked with up there, he was telling me that they just got funding to start like a vertical farm up in Alaska. And, if you don't know anything about Alaska, basically like one company controls all the food deliveries out to all the villages, and it's basically just junk food, like literally chips and soda pop, and like people have horrible dental health and a lot of obesity and other stuff. And it's like, man, so we started being like, oh yeah, we could start a farming thing and we could really provide like food security for Alaska. And sure enough, yeah, they're my friends, they've stuck to it. And they've got like 40 villages already on board to take food from them as soon as they want to do that. And then the beauty of it is like they're doing it all as a co-op, right? And under that premise, it's not like we're not trying to maximize profit to our shareholders. Like, I mean, we're doing everything like project based, and then the point of all this is just to try to actually reach the community and try to bridge academia and business and actually meeting actual people's needs. There's just like a lot of opportunity for this right now, especially in the US, because we don't have a lot of I would say it's interesting because we have like the state of the art, but then we don't have a lot of people I would say that are very well educated, or we don't have these resources sort of built out in a way where that's like very accessible, right? You need lots of teams of specialists to operate all this hardware. You need $100,000 to get a hold of half of these devices, well, let alone half the team that's qualified to use it. And there's really no reason for a lot of that anymore. It's because it's just so accessible. And there's a lot of things we can do design-wise to make it that accessible, especially for just anyone, I mean, researchers and clients that need health treatments or whatever we could do with this stuff. I don't know. Long rant. So this is my master plan here, right? So we're prototyping. We're coming up with MVPs. We're getting our technology just absolutely locked down to something that should be easy for us to, for one, we know the data is going to be absolutely good, and then it's like affordable enough we can mass produce it if we ever get to that point with funding. It's all just going to be a slow climb up, and then we've got a lot of potential partners. Buckle up, now we're calling that Alice, but that's our rehab project, and lots of the Facebook thing didn't pan out. We almost had a Facebook grant, maybe. But BCI for kids, that's we're working with kids with cerebral palsy. BCI guys, they're just a couple of students, I think, in Calgary. We're working with them now. Oh God, there's like a dozen other collaborations kind of brewing. Anyway, but what's cool is all of that is being brought into this open source umbrella and this community-driven model. And then, if we can make that viable and make this a really nice way to generate some resources, then we can just keep growing this perpetually and provide, the most functional, most affordable, most accessible, like biotech, well, neurotech, and eventually whatever else we can get into. But, we're going to be like the nexus point. That's the goal with this, right? And hopefully we have you all along. But this is just some word notes. But part of this is like, if we want to build a sustainable, ethical business, we got to get really serious about like supply chain modeling, and if we want to make sure we're providing like jobs for people and that they're actually getting paid fair wages. I mean, I don't pay anybody who works for me less than $25 an hour. It's like that's still too little. It's like crap. I want to build a really cool business that just makes us all really happy and can sustain us, and has a sort of really cool community vibe to it. Anyway, so that's it. I'm going to go into a little bit of just demonstration here. So this is our platform. This is all alpha. We're doing a lot of reworking right now just to make, so Garrett has this studio program here. Essentially, this lets you visually, like we have all these I mean, we've got tens of thousands of lines of code now, so we're just working on packaging it all up into like a visual system, so you can access all the algorithms, and then this when it's working proper, whatever it should have stuff in it. Here we go. So when this is all working properly, like it lets you live edit applications, and then if I like simulate data coming in. It's probably a little broken, but it does show the data, being passed live. All in transition, but kind of a cool visual flow graph system. And then when this is finalized, like, I mean, this does kind of work. It's just we're fixing it more. It actually lets you download the whole application, and this can be loaded into like an app or well, it's packaged right now for progressive web apps. Anyway, so we support all these devices, OpenBCI, free AG13, my devices. You have sensory use, veracity motive. We're working with more devices. Oh, even eye tracking, WebGazer. We haven't. I mean, it's there loosely. We haven't implemented the data, whatever, like saving the data for you. But we can do all that in the browser, and it works great. Let's see. So I'm simulating data coming in right now. Let's see, this is the performance. Sorry. Yeah. Okay. Here. Yeah. See, like I got to fix this graph, make it perform. Yeah, whatever. So he's like simulating an FFT right now. Wow, this is broken. Oh my god. We're just simulating data coming in on a channel. So it's just like a sine wave being simulated. But you can see it being streamed. And then, like I said, it's just streaming. So like I can go into any of these apps while it's streaming in the back end. And when this is actually, oh my gosh, when this is actually functional, like this would be animating, say with whatever neurofeedback you're putting into it. So we're trying to make like a professional workflow out of all this now, plus all the performance. Oh my god, the performance optimization. It's quite an ordeal. But what this will be like, we're going to make it so it's like a typical neurofeedback application, except it'll have the studio baked in. So you'll be able to essentially remix the app with whatever you want, and then that'll become like a staging point for us to invite the community in to help us actually build all this, to build plugin functionality, to build visual features, and then we can essentially have this really cool workbench. I mean, starting with neurofeedback and signal analysis. Oh, what the other thing it does too, I should show. This is also backing up your data. Oh my god, if I can find it. Session. There we go. Let's see if it visualizes. Refresh. Here we go. Yeah, so here's a graph of like an Ecg session, right? So I can zoom in, you can see my pulse going. And so this would be, with my Ecg, this is this device. This is my my overall blood oxygen saturation. So then as I'm, whatever, it's like a 6-minute session. With the Ecg, you're just trying to raise that lineup, and then what that tells you is relative blood oxygen saturation in your brain, which tells you relative metabolic activity. And then in general, you're trying to increase that perfusion as much as possible with that type of biofeedback. And there's all kinds of really interesting neuroscience related to that. Anyway, so it's like, okay, say I did some biofeedback, now it's here being tracked, and I can download it. We have some loose Google Drive integration, and I don't know, all in alpha. This will all get better, but we're trying to turn this into something actually professional. So it's like a plug and play, free neurofeedback template thing, and we're going to build like a whole thing of like a whole set of community resources with all of this, so that like if you're contributing, like you'll have like your profile, and you'll be able to like search, say John made this thing. Well, I want to go to John's profile and pull his resources. I don't know. I love Little Big Planet. I love the game Dreams, and it's like we got to have an element of that, of like just playing around, doing whatever, having like a cool way to present how everybody's contributing to this. Anyway, so what? I think that's pretty much it. I don't want to talk too much more, but you know, let me look at all these. I see there's a lot of questions here. I want to chat.
I was going to say you can hop onto the questions. Yeah.
So okay, so VR XR support, we already have that through 3JS. It's kind of janky, but I don't know. We'll figure it out. But it's definitely like it's like one line of code. Yeah, go for it.
So I mentioned in the chat that we're running the BCI Game Jam along with the BCI for Kids program at the University of Calgary. That's going to be this weekend, or sorry, this upcoming weekend. In that, we do have plans for integrating web builds from Unity into the browser and then being able to interface brain data that way. They also have some tools for using brain data in Unity and, you know, quote unquote serious VR XR games. It's difficult. So the second question is, you know, what coding language would you recommend to learn to adapt brains at play? JavaScript, plain and simple. And that doesn't play well necessarily with all of the serious VR XR frameworks. There are integrations that are possible, but they're not like
kind of low fidelity stuff for the web.
Yeah,
it's getting better.
They're not direct in terms of like building a Unity project and scripting in JavaScript. Like you'll have to.
Well, we're getting Vulkan next
week,
so we're getting web Vulkan. So we're gonna have GPU computes and all that other stuff. Hopefully, you know, in 5 more years when somebody finally develops an engine, or maybe that'll be us. Okay, what else?
Yes,
Technical challenges.
Oh, sorry.
Go for it.
Yeah, I've been trying to integrate the brains at play with Unity, but with no success so far. But yeah, I mean, if you will choose between somebody that is a beginner and choosing between Python or JavaScript, which one would you recommend? Directly JavaScript?
Yeah.
For doing all this?
Oh yeah. No, it's just straight JavaScript. We don't.
Is JavaScript the language of the future of PCIs?
I mean, well,
that's what we like to think.
Essentially the future of like end user applications, just because like we're kind of moving away. Well, at least these the web overlords want us to move into like essentially like dynamically decentralized served applications on the web. So like ours is just a web page. It only downloads what resources it needs, and as you're going through the site, it's only delivering what files it needs. So like if you go to a 3D rendering example, then it pulls the 3D rendering library for you, right? Rather than being like, I'm going to download 300 megabytes of stuff all at first. It's actually all distributed. There's a lot of other advantages to that. There's a lot of security advantages and other things that are just kind of baked in with the web. We do everything client side otherwise. So for us, we just mainly care about performance, which it's there now. Not much you can't do.
People's data never goes to a brains at play server. It only stays on a.
Yeah, only if you want to do multiplayer, and then we'll add some like opt-in stuff so that we can help facilitate like research. Like if someone wants to make an application to test, you know, attention or something, you know, we could make a framework so that people can offer, you know, participate in that stuff like willingly. I don't want to have some. I was telling Garrett, I don't want to have some, you know, license that's just like, you agree to give us everything and you can't say nothing. You know, we're trying to keep it all in the hands of the users because that's what's interesting. That's what people want. This is what I want. We're just trying to make it really convenient.
I think we have more questions. Rodolfo says, what was the most challenging technical issue in the developing of the MVP of Brains at Play, and how you solved that issue?
Honestly, it's just like learning. Like basically the web lets us apply systems willy-nilly because it just has so much baked into it. And for us, it's just been a lot of like I'm applying the fullest extent of my coding experience here. And I'm having to understand all the systems engineering and everything else that goes into actually building a fully fledged system. Because I'm trying to say, I want this to be something you can be basing your whole applications off of, and you can be publishing stuff that uses our stuff as like a backend, and then where it's very little work for you to actually finally do all the, you know, just wiring together devices to do whatever analysis to make whatever cool thing happen on screen. Like I want that part to be easy. We're taking care of all the performance and everything else, and then leaving all of that open so that anybody else can come in and help us improve that at really at any level. So trying to make something that works and is also completely like modular, it's kind of crazy. It's using a lot of just like, well, I mean, literally everything the web has to offer in 2021. We're taking advantage of it.
Awesome. Is there any chance that you guys integrate some sort of neurostimulation technology to Brains at Play? Like, I know you're working right now on this spectral.
Yeah, I mean, it's really just if someone wants to. We haven't had anyone approach us yet, being like, "Do you want to do neurostim?" I mean, it wouldn't be hard to, I think, add software support for that. Now, us actually making our own neurostim devices, I don't have plans for that. It's not really my expertise. I'm all non-invasive. It's very interesting. I'm working with a guy. He's working on a 24-channel amp that also has TCS, I think, or TES baked into it. It's expensive clinical stuff. It's not cheap.
Interesting.
Anyway,
how can people help Brains at Play? Like, how can people collaborate with this open source project?
Yeah, I mean, we're still a few months out from sort of being able to like be like, okay, go, like everybody come and do what the hell you want now, because we have a lot to do, just refactoring the library to be exactly something that people will actually be happy working with, where we don't think we're going to have to dramatically rework things anymore, which would suddenly, like right now, what we're going to do is going to break literally everything, and then we got to fix it all. So we got to get over that, and then we're going to be at the point like we've got to get a bunch of stuff together, basically. Until then, I mean, start doing web, man. Like, you're going to need to know that if you want to work with us. Yeah, I'm like so in my head right now, just trying to get the work done. It's hard to say, like, yeah, come do this with me.
People will have to
make
wait.
It good first. Yeah, just a little longer though. We're almost there.
If I want to learn how to use Brains at Play for myself, is there like resource available for me? Like
we have old docs. Otherwise, talk to us because
yeah, just talk to us.
We'll help you.
Okay.
Yeah,
you have a
all in
Discord
transition
server, right?
Yeah.
Maybe you can share
a
link
link
through the chat, so everybody that is interested principally can join.
Oh, there's one more question. If I'm
Yes.
developing a webinar based for BCI user training, so that's what we're doing, is we're trying to make an actual training interface. I mean, it'll just be a data collection interface, but we're going to make it really easy to put the visual features on and say, I want these devices and I want to do this analysis, and then, and then actually seeing your data afterwards. We're trying to make that workflow really straightforward now. So taking all these, essentially this tech demo and making an actual application that's like, you can actually use it really easily without any questions. Right now, if you tried to use this, you'd be like, what is going on with these?
Is there a way that people that is working on their own like EEG device can integrate it to Brains at Play?
Yeah, all you need to do is have an open driver. Like we just need to know your driver protocol for either USB or BLE, and then it takes us 10 minutes to create. And we've done, I mean, really any kind of device that has a stream. I mean, I'm thinking eventually we could be accepting like any kind of, it's just signal analysis, right? So you could get any kind of equipment streaming into this stuff, like, I don't know, remote environmental analysis or something. It's all interesting.
Do you show us like a prototype of this FNeuro device? And this FNeuro laptop? Yeah. How much is going to cost? And when is going to be available?
This one, I have no idea. What it's going to cost? Well, what our boards cost? We haven't quite settled on the price yet. The boards are not going to be more than like $60, and then this headset. This won't be more than $200, and then the 28-channel version won't be more than $300. I have so much math. Actually, if any of you guys know tomography, or no, you don't even need to know tomography. You just need to know how to do voxels and collisions. Then help me. It's like, I'm supposed to learn that and like machine learning and crap. I need a bigger brain.
Well, you tell us that you drop out of school. Is there a chance that in the future you'll come back, or do you think that it's completely useless for you right now?
Well, I mean, currently it's useless, but I really love medical psych, and I'm really I'm really serious about trying to get into some kind of clinical path at some point. But there's so much work to do, just like actually making this. Like, I'm an engineer. I'm not just like a guy who can be a therapist, and I'm not just a guy who can like do research. Like, I'm an engineer. I got to build stuff, and then what I want to see is that I can make this so accessible that then I can bring this hopefully to thousands of people, and we can start to extend all the benefits of modern neuroscience into the actual real world, because we really need to do that. And there's all kinds of other things to tech. Tech literacy, democratization, trying to build global networks where we can all just work together and not worry about politics and other crap, right? And trying to actually build good, healthy networks for all of us to participate in. That's all part of this.
Yeah, it's a very nice ethos, I guess. And well, I really like Brain Play since the beginning, since I first heard of it. And I wanted to ask this question from the beginning. Why did you make it open source? Like, what is the reason behind?
It's the right thing to do. I mean, so this is essentially low grade medical. It's like medical-ish technology, but the same hardware is used in all kinds of actual medical scenarios, except like in the US, we charge obscene money for all this stuff. And like, there's really no reason. A lot of other stuff gets locked up behind patents and this crap. And my opinion is like, if we're actually trying to help people, then we need to be adopting the moral principles that are actually we need to put our money where our mouth is, right? Like, at the end of the day, it's not about making money or any of that. It's about actually making people's lives better and seeing our work actually mean something to people, right? And with open source, it's an invitation for everybody to come do that with us and actually validate this stuff against academic scrutiny. And I mean, I don't think we should hide any of this, and I think we should try to make this stuff as free and as accessible as possible. Because, I'm pretty damn privileged here in the U.S. with all the resources I have access to. But I know all these third world countries that haven't heard of most of these things, even I worked with a guy in Brazil, and on an early version of this. They're actually going to publish. It's called the State Changer. I just stopped working with them for other reasons. But so this guy Diego, he has a master's degree in computer vision in Brazil. He was like one of the first guys ever to do it. And then to work online with me, he literally had to climb up a mountain and hook up into his friend's AT&T tower. It's like some antenna that he had for research. And he lived in a favela. It's all these things where it's like, oh my God, here's a genius who has almost nothing to go on. And then for him to do this hardware project with me, he's basically relying on me to get stuff done for him. And it's and to get that technology brought into even for me just to send prototypes to him, there's insane tariffs and other stuff we had to jump through to make it happen. It's it shouldn't be that hard. We need to make this easy, not just for ourselves, but for all these other people in these other countries that they can't pay money for, they can't afford this shit. And then we're sitting here oh, I'm going to charge $500 because of my glorious time and money that I spent on it. Yeah, that's going to get absolutely nowhere. And I can see so many people who could just actually start to get this, get a hold of this technology. There's so much education, not just in the US, but worldwide, that we can improve, I think, if we can make this stuff really accessible.
So right now, the current open source license that Brain Play has let us...
AGPL.
So basically, what are the limitations of that license, if there is any?
So AGPL just says that if you base something you're doing off of our library, like you build a plugin or something, then you have to also publish that open source. And then AGPL provides some additional protections, because the regular GPL, we found out if you published a distribution on a server, you could update that distribution on the server without publishing any of your source code elsewhere. So this adds some additional protection. So what it is essentially it's a license that maintains that everything is going to sit in the public domain that gets added to this library. And then, if you have some patent project that can't be AGPL, well, there's still ways to work with us. It's just you would have to AGPL your code if you were going to base everything you're doing off of what we're doing, or like off of what we've provided, because we're trying to cover as many bases as possible so that you can just plug into the web and do whatever you want with biosignals. So that's AGPL. We're anti-privatization here.
If somebody wants to use this technology commercially, they can do it, but they have
sell
to
distribution.
Also distribute.
Yeah. So like what we're planning to help us make money is not just sell hardware, but like we can package up our apps and sell them on the App Store, for example. And we're trying to make this all super easy, because then it'll be easy for us to get our software like anywhere. So there'll be ways for us to sell distributions of this, and most of it'll still be free and open source. But there's ways to monetize. And like if you want to partner with us, and release an app, you can easily charge money for that. It's just we're going to open source the code and the functionality as well. And it's not like most people can replicate that. Or if they will, they'll probably just copy you, and they're not going to do a great job at it. So don't worry about it.
Awesome. If somebody here listening to us wants to maybe get a EEG device, which one would you recommend?
Well, to just jump in and use, I would say the one we haven't released yet. I would say if you want to just play with data like a Muse or something, it's probably the best option. We're going to have this 32-channel EEG, and that'll be plug and play. But that's a technical instrument. It's not just something for people to play with. It'll be cheap enough that you'll just be able to play with it. But
yeah, I second that on the Muse. It's the cheapest option right now for getting any sort of real-time data, but it's not great. So, I mean, you can't really get anything interesting in terms of things like P300 or motor imagery. Like you're getting blinking data and maybe some like frontal activity that corresponds to concentration.
You get simple, yeah. I mean, there's a lot to learn just there.
But it does allow you to get very familiar with real-time data streams, which is exactly what you need here.
Which one, sorry?
Just the Muse 2.
Oh, yeah.
You can get it for like, at least in the US, you can get it for about $200 on Amazon.
Yeah. It's so bad, it's great, right? Bless you.
Exactly. It's also so easy to just take on, take off. It's the only one that I use to prototype, to be completely honest. And I have an OpenBCI. Just saying.
Yeah, awesome, guys. I don't know if we have more questions.
One more. Some guy.
I have a question for Josh.
Sure. Go for it.
Thank you, Josh. For people to have a cool project in biotechnology or neurotechnology, and they want to maybe work with you or
for sure.
make this project as a kind of open source, how they can reach out to you, or is there any platform to talk about this kind of thing?
Just email or Discord. And then, we basically committed our company to doing everything AGPL. So we made this decision of if we're going to work with you, you got to AGPL it. This is our little, it's our little proposal, and then that's it. Everything else is, let's make it work, and we'll find the best ways. I mean, we're just doing a lot to try to make this, finally easy to open up to everybody, and then until then, we'll work with you in whatever ways we can. And we're just working on getting to the point of actual synchrony with everything going on that we're doing.
Okay.
So you can just download our stuff and it just works, and you don't have to ask us anything anymore.
Okay, good. But by the way, I think you are more maker and inventor rather than interpreter. Thank you.
Yes, Maxi here asked if we want to build our own device, what resources do you recommend? I think this.
I really loved. Arduino is how I got started. I released my first device just using your Arduino firmware because it's whatever, yeah, it just works. That's the greatest way to start actually learning microcontroller coding. And then the other thing you need to learn is about analog signals. And I mean, the easiest thing to do is get an ADC, an analog to digital converter, and start learning how to use that with a microcontroller. I'm working on what I'll have here is this will be a full microcontroller solution with a Ecg quality ADC on it. So this will be the cheapest thing you'll be able to get here once we're able to publish it. But otherwise, if you want to learn it yourself, yeah, there's that. You need to learn Eagle or KiCad. I prefer Eagle, but it's a private software. But you can do for free. You can do 2-layer boards in like a small area. So that's enough to start messing around. Look into PCBWay. They're the company I pretty much use religiously for fabrication and assembly. There's plenty of other options, but I mean, once you find one that works, it's kind of hard to deviate. Plus, they're really cheap, so it's like $5 to get 10 boards made for you, and then they have a deal for simple assembly. They'll do 10 boards for $20 for you as well. So really easy now to actually get into making your own things. I really recommend it because more people need to do it. That's how we're going to open this field up. More people start to master it, want to share their work. Come on, guys.
Yes, definitely. More resources also, maybe tutorials on how to use.
We're getting there too. All in the pipeline, man.
Yeah,
if
it's open source, the community can help too, right?
Yep. No, it's just a matter. We're in a point of trying to get up to where we can easily have anybody contribute. It'll be all fully documented, and we'll have all the systems, aligned in the way that we are envisioning. It's just a lot of work.
An estimated time?
Hopefully within 2 months. I mean, it's all a process, man. Sooner than later. Let's put it that way.
Sorry, Hamid, you were saying something.
No, I just a question about the KiCad or Eagle. Josh, do you think is anything special that we can do with Eagle that KiCad cannot?
My only opinion, well, KiCad just makes it really, it's like MS Paint. Like, it's like really easy to use. And then it makes it really easy to process the files that you need them to do. You have to create assembly files from your drawings, and it handles all that for you. I mean, KiCad's gotten a lot better, but it's just like the presentation is kind of information overload in KiCad comparatively. Eagle feels like I said, using MS Paint. Way easier to learn. There's so many mistakes you can make, so that helps a lot too. But it's a lot easier to interpret what you're actually looking at.
Right now, is there a way to load my own .csv files to Brainsaplay and play with that? Or
well, right now they're only we don't have any data replay stuff going yet. Right now the files are just the format that we have, which is just a really simple format. But I mean, I could show that to you if you wanted, but we have so much I wouldn't even recommend bothering yet. Like we've got so much to fix and make good, and do the presentation, everything else. So just wait. I can teach you how to load CSVs into an HTML file. That's pretty easy. Do some graph. The JavaScript's enough of a challenge to learn.
Yeah. Is there plans to make this mobile, like an app?
Yeah, it works on mobile for the most part.
Yes, yeah.
So any devices with Bluetooth, any devices with Bluetooth can.
Well, iPhones won't connect, unfortunately. But I mean, except if you're on Chrome.
A problem to solve.
Even if you're not on Chrome, I'm not sure. I don't think so.
You have to figure out what to do about
That's just Apple being a pain.
iOS, They're just
That's the thing, right? For example, the Muse headset can connect easily with Brainsaplay through your mobile phone, but the OpenBCI doesn't, because it has this little dongle that needs to be connected somewhere, and
which, by the way, is $150 because I lost mine.
Yes.
And I will probably not be replacing it.
Yes, thanks to the chip shortage, everything, all the prices went up, and it's terrible. I mean, why they
Yeah,
even
we couldn't
use
even escape that.
those stuff, those dongles? But well,
I don't know.
yeah. So if there is no more questions, I would like to invite everyone to the next part. That is the networking session we have here at Gathertown. So this is going to be a fun experience. Guys, please, Josh and Garrett, please, you're welcome to join us too. Maybe we can try to demo it live here in Gathertown. Everybody is welcome to join. We have our signature NeuroBar session. So we'll be discussing and chatting with people from all over the place that is interested in neurotechnology. So thanks again, everyone. Thanks, everybody. Thanks for being here. I don't know if Hamid would like to say something else.
No, just thank you to all of you. And I encourage all people, especially in Mexico City, to join to our chapter. We have a lot of things to do especially for next year. So I encourage you and I'm waiting for you. Thank you to all of you.
Yes, and the same thing goes for all the people here in Bolivia. Si alguien está en Bolivia y le interesa ser parte del chapter que tenemos en la ciudad, igual está invitado. Y bueno, somos un grupo de hackers y de personas que nos interesa este tipo de tecnología y la neurociencia, ¿no? Entonces, son libres de unirse a la reunión en Gathertown. Ya está en la sesión de chat, en el chat. Y bueno, si necesitan ayuda o algo, también estaremos ahí para ayudarlos con Gathertown. Voy a parar la grabación.